So this is problem 16 of chapter 20 of Giancoli 6th edition. So what we have is, the question is, what is the velocity of a beam of electrons that go undeflected when passing through perpendicular electric and magnetic fields? And they give us the values of that electric field and that magnetic field. Okay, but let's try to understand what is going on in this problem. So we have a whole bunch of electrons that are being sent with a certain speed. We want to find what is that speed, and they get to a region where we have magnetic field. So let's start thinking first about the magnetic field. Okay, so these are electrons. Once they get in this region with this magnetic field, their trajectory will get deflected. And how? Well, if it was a proton, we know that the proton would feel a force pointing up. So that means if these are electrons, they will feel a force pointing down, and we are going to go into this loop. We would go into this loop if all that we had was this magnetic force. Okay? But they are telling us that these electrons get undeflected. They just go through and they maintain that straight line. And why? Because on top of this magnetic field, we also have an electric field. An electric field that prevents this deflection. That means this electric field is right opposite to the electric field. The force caused by this electric field is just opposite to that magnetic force. Okay, so why the electrons go straight through this? Now it keeps it straight line because the magnitude of the electric field the magnitude of the force caused by the electric field is equal to the magnitude of the magnetic force. Okay, so what is this force caused by the electric field? Is the charge of the electron multiplied by the electric field. And what is the force caused by the magnetic field? So that force is the charge, Q, the speed, and B. So the charge is the same. We are just talking about electrons here. So from this equation, we can find that speed of each one of these electrons. Okay, so this is the part A of the problem. Part B now. Part B will ask us what is the radius of the electron if the electric field is turned off. So if we turn off the electric field and therefore turn off this force caused by the electric field, then we do have that circular motion. Okay, so how are we going to get the radius? Remember, that magnetic force will now cause that circular motion, so will give us m centripetal acceleration v squared over r. So from here we'll be able to get the r. The v we already found. Now we know what is the speed that these electrons are being thrown. Now is what we found in part A. And what is this magnetic force? Well, it's Q. Q here is just the electron. V, B. And this is equal to m v squared over r. So we know what this V is. We know the magnetic field. We know the mass of the electron. We know the charge of the electron. And from here, we'll then be able to find the radius.